Okay, so let's look at the first word problem. It says, Mary sold 49 tickets for the school play. Student tickets cost $3. So just give ourselves a visual. That's the student ticket and it costs $3. Continuing to read, it says, and adult tickets cost $8. So again, as a visual, there's an adult ticket and we know that it costs $8. Mary's sales totaled to be $287. How many adult tickets and how many students' tickets did Mary sell? Well, first of all, before we even attempt this word problem, we should probably explain in words what happens. So in this case, let's try to explain how she sold a total of 49 tickets. I know what you're thinking. You're probably overthinking this problem, first of all, so let me just explain to you. It's as easy as stating the obvious. All we're going to do is take the number of student tickets and we have to add it to the number of adult tickets. And we know from the word problem that it should equal 49 because that's how much was sold. Now let's look at how Mary got a total of $287. Okay, we'll think. If one student ticket is $3, if I sold two, it would cost $6. If I sold 10, it would cost $30 altogether. If I sold 20, it would be $60. So hopefully right now you're noticing a pattern. All I'm doing in order to get the total is I'm taking the number of student tickets, then I'm multiplying by the price of the ticket, which in this case is 3. So my setup right now is the number of student tickets times 3. Now that we have dealt with the student tickets, we need to deal with the adult tickets. So again, it's the same pattern. You're going to take the number of adult tickets and multiply it by $8. And according to the word problem, again, it tells us that it does equal 287, so that's what it's going to equal. But now, because in order to solve this problem nicely, we're going to have to assign some variables. Why? Because we don't know how many student tickets were sold and we don't know how many adult tickets. So we're going to use a variable. I personally am going to choose S to represent the student tickets and A for the adult tickets. So right now I'm going to turn the sentence I have created for myself into an algebraic equation. So if we notice, S stands for student ticket. So right here, for number of student tickets, I will write S. Plus, what's the number of adult tickets? Again, I used A to represent that. So in the end, I'm going to get S plus A equals 49. Now over here, the number of student tickets times 3. I know what you're thinking. First, you're going to do S times 3, but in math, we don't write it that way. We write this number, which is called the coefficient, before the variable. So we would write it as 3S plus number of adult tickets, which is A, times 8. And again, we don't want to write A times 8. The 8 is a coefficient, so it must go first, so it will be 8A. So in the end, I'm going to get 3S plus 8A equals 287. Now we have a system to work with. In this particular lesson, we are supposed to solve it by using the elimination process. So here, I'm going to ask myself, will it be easier to eliminate the S's or will it be easier to eliminate the A's? So first of all, if I chose to eliminate my S, I would see that I'd have to multiply this first equation by negative 3. Now let's look at our other option. If I wanted to eliminate my A's, I would have to multiply this entire equation by negative 8. Personally, I would choose to get rid of my S just because I would only have to multiply by 3 and I would choose the smaller number versus the larger number. I would prefer to keep my numbers small. So in this case, I will go ahead and multiply this entire equation by a negative 3. And please understand, I do have to multiply by a negative because if it was positive, things will not get eliminated. So I'm going to go ahead and change to see what this equation is going to turn into. It will be negative 3s minus 3a equals negative 147. All I did there was distribute the 3 to each and every term. Now, the second equation, you don't really have to change because we want it to be a positive 3s. That way, right here, we can see that these two terms will cancel out. leaving me with just 5a equals 140. Next step is I need to isolate my a, so I need to get rid of the 5 by dividing both sides by 5, leaving me with a equals 28. Technically, right now, we could use common sense and ask ourselves, well, how many tickets were sold in all? Well, in this case, there was a total of 49 tickets. If you ask yourself, if there was a total of 49 tickets were sold and 28 of them were adult tickets, some of you might be able to tell me right away how many student tickets were sold. But if not, what you're going to have to do is substitute it back into one of the original equations. I would choose the first equation just because it would be easier to substitute in. So I'm going to go ahead and substitute a for 28. I'm going to solve for s by isolating it and by getting rid of the positive 28. I subtract 28 from both sides. This cancels out, which is what I wanted. I'm going to get s equals 21. So let's go ahead and try to explain what these variables represent. Just as a reminder, this S stands for this number of student tickets. So I can say that there are 21 student tickets that were sold. And this A represents the number of adult tickets. So I can say 28 were adult tickets. So if I were to answer the question, I would say Mary sold 21 student tickets and 28 adult tickets.